So this was a pop quiz which was related to topic DC electricity. In the first question, there's an increase in light intensity for a light dependent resistor, and this caused the number of the conduction electrons and the change in the resistance. Because LDR is a semiconductor, so when the light falls, it produces more electron and hole pairs. As a result, the number of conduction electrons will increase. And as the number of conduction electron increase, what happened to the resistance? The resistance will decrease. So C will be the right answer. In question 2, a uniform wire is attached to a meter rule. The wire is connected in the circuit as shown. The distance D of a connection to a voltmeter increases. The reading on the voltmeter changes. Which graph shows a relation between V and D? Like if this D was 0, like if we were not using any length, if this D was 0, if there was no length used, the connection of the two ends of the voltmeter connected to the same point, so there will be no potential difference there. But as we increases the distance, if we increase the distance between the 2 points, what will happen? Because it will have a greater resistance means greater potential or a voltage drop across that component. So resistance and length are directly proportional to each other, and higher resistance means more voltage will be there across. So it cannot be negative voltage. This is wrong. This is also wrong. Here, this shows that the voltage is, if we have a wire and we have a voltmeter, so because we are increasing this distance, so resistance increase voltage or resistance increase the voltage or potential across that component will also increase with the length. In question 3, the diagram shows 1.5 volt cell which is connected to two resistors. The cell has a negligible internal resistance. The switch is closed. So if we close the switch, means this will be a short circuit. Why this is a short circuit? Because short circuit means like the least resistive path, the current, it will follow. So what is the conventional current? When we close, this will be a short circuit. So there will be no current. Like 5 ohm is not the effective part. And only one resistor is there, that is 10 ohm. So how much is the voltage? That will be same as the EMF of the cell, that is equals to 1.5. So D will be the right answer. Because it is being short circuit, that's why if there was another component was connected, any known resistor like 2 ohm, 3 ohm, then some current will flow through 2 ohm, some will 5. But whenever like no component is connected, that will be a short circuit. So all the current will flow through the short circuit. So this 5 ohm is not a part of the circuit as anymore. So the total EMF in a one loop is equals to total potential difference. That's why it will also be 1.5 volts. Question 4, a circuit contains a filament bulb when the potential across the filament is 8.9 and the resistance is 7.5. Calculate the time for a charge of 5 coulomb to pass through that point. So first we'll use a formula V equals IR, where V is the voltage, that is 8.9. Current we don't know, and R is a resistance, that is 7.5. So the 7.5 is multiplied, other side divided. 8.9 divided by 7.5. So we get 1.19 ampere. That's the current. And after getting the current, we have current equals charge divided by time. So if we need time, time is charge divided by current. So charge is 5 and current is 1.19. 5 divided by 1.919. So it will take about 4.2 seconds to flow. Question 5, a student investigated the EMF and the internal resistance of a battery. The student connects a high resistance voltmeter. The battery is not connected with any component. Why? The reading on the voltmeter gives an EMF. So We have a battery with internal resistance, and the student connected a very high resistance voltmeter, and the battery is not connected to any other component. So what will happen when we have a very high resistance voltmeter? There is no current in the circuit. So the current will be zero. And when the current is zero, at that time, the total potential difference will be equal to total EMF. Because we have the formula that EMF is equals to I small r plus the external voltage. Because of a very high resistance, the current will be zero. When the current is zero, so this factor will be zero. So we can say EMF is equals to V. So when you write this answer in your own words, you will mention due to high resistance, the resistance of a circuit is high. So no current flow. So as the resistance of a circuit is very high, there will be no current will flow through the circuit. As no current will flow through the circuit, the total EMF will be equals to total potential difference. If we draw the current, then there will be some lost voltage in internal resistance and remaining the voltmeter will record. The student investigate how the potential can be varied. Draw a circuit. This is a circuit you have to learn for finding the internal resistance of a battery. So this is a battery with internal resistance. We connect a variable resistor. And you can connect a voltmeter in parallel to variable resistor or in parallel to battery, and ammeter in series. And there will be a switch. So voltmeter in parallel to the battery or in parallel to the variable resistor, both are correct. The student plotted the results between the voltage and current. So when we have a VI graph, remember for IV graph or VI graph, the slope represent the negative of internal resistance, and the y-intercept is actually equals to EMF of the battery. So this is the y-intercept, which is 8.8. So EMF will be 8.8. And we'll use a gradient formula, like take any 2 points and y2 minus y1 over x2 minus x1. That will be the internal resistance. So determine the EMF and internal resistance. EMF, you just have to read the y-intercept. And for EMF y-intercept and for internal resistance, take any 2 points. But the spacing between the 2 points should be more than 5 centimeters. Anywhere you can take those points, but the spacing should be more than. The first point on x-axis is x1. First point on y-axis y1. You will get a negative gradient, and that negative gradient is equals to negative of the internal resistance. Like when we find the gradient, our gradient will be negative, and the gradient is equals to minus r. So negative will cancel with negative, so gradient will be equals to r. Explain why there is a maximum current that can be supplied to a explain why there's a maximum current that can be supplied to by the battery. So what actually happened, because as you can see, the potential across the terminal, as it is decreasing, as more current is there. So why the maximum current that can be supplied by the battery? So this is actually a maximum current which can be supplied by the battery. So what is actually happening? We have the formula EMF is equals to IR plus V. So when this factor is increasing, like when the current is increasing, the potential across the cell is decreased. The sum will be constant. Like this factor will increase, the potential across the component or potential across the cell will decrease. And at a certain potential, like at a certain, like when, what condition when this potential will be zero, example. So when the V is equals to zero, as a result, what will happen? EMF is equals to IR. And this I will be the maximum current which can be supplied. So according to the graph, as we draw more current, the potential across the cell is decreasing. And at a certain potential, like at zero potential, the maximum current passes through. And when the maximum current passes through, in that case, the EMF is equals to the potential across the internal resistance. So the points which you will use to answer this part, like why there's a maximum current, why not like current increases just when we increase the potential. So when the current increase, the potential across the variable resistor or our external potential difference decreases. So when the current increase, the potential across a variable resistor decrease. And the potential across the internal resistance will increase. And when the EMF is equals to potential across the internal resistance, the current will be maximum. Is it clear? So when we are increase, like as we reduce the external resistance, there is more current. More current means like less external voltage, more internal voltage. Once there is no external voltage, all the voltage drop internally, that time will have the maximum current. That's the part. In question 6, a metal rod on the top of a church may have been seen the word first lightning conductor. The metal rod is connected to the ground by the steel cable as shown. When the lightning strike, the charge is transferred to the metal rod and is conducted to the ground. The steel cable has a diameter of 12 millimeter and has a total resistance of 0.078. Calculate the length of the cable, the resistivity is there. So the formula R equals rho L divided by A. So if we need length, so it will be RA divided by rho is equals to length, where R is a resistance 0.078, A is a cross-sectional area, but we have a diameter and that is in millimeter. So divided by 2, we'll get the radius in millimeter, which will be 6 millimeter. And millimeter, we have to, SI unit is meter, so we have to convert. So it will be 6 into 10 to the power minus 3 as we divide by 1000. This will be the resistance multiplied by area. What about area? Area is pi r square or pi d square by 4. So in place of r, you can write the radius, which is 6 into 10 to the power minus 3 square, and divided by the resistivity. The resistivity is given 1.4 into 10 to the power minus 7. So when we divide all of them, we'll get the length. This will give us the length of a wire which is used to produce this, which is about 63 meters long. During the lightning strike, there was a potential of 1.5 exponent 8 volts. between the metal rod and the ground, the potential cause a current of 1.2 exponent 4 ampere for 70 microseconds. We have to calculate a work done, means energy. We have the formula like voltage is what? Voltage is work done per unit charge. So if we need the work done, so work done will be voltage into charge. So the potential which is across the lightning conductor multiplied by the charge, how much charge it will flow. And we can also modify this formula as we have current is charge divided by time. So if we need the charge, so charge will be current multiplied by time. So we can say voltage into current into time is equals to the work done or energy. So voltage is 1.5 into 10 to the power 8. The current is 1.2 into 10 to the power 4. And the time is 70 micro. This is for micro, means 10 power minus 6. So 10 power minus 6. When you multiply, you will get your answer in joules, which is 1.26 exponent 8. So that is 1.26 exponent 8 joules, the total energy which is transferred in 70 microseconds. In part C, the steel cable is replaced by a copper cable. The copper cables have the same length, same end diameter. During a thunderstorm, the potential between the metal rod and the ground is same as it was for cable. The copper has a lower resistivity. And there are greater number of the conduction electrons per unit volume, like greater number of charge carrier in copper than in steel. A student stated that the drift velocity of electron will be same in both cables. Assess the student statement. So first, we'll use a transport equation. According to transport equation, I is equals to NAQ, V is there. So first we write the transport equation where N is the number of charge carriers or charge density, and A is their area of cross section, V is there, and Q. In the question, like if we are comparing, we have initially it was steel, but now it is replaced, the steel cables are replaced by the copper one. In the question they mentioned they have the same length and same diameter. So this factor is constant. This Q is also constant, which is a charge of electron. So we are left with N and V. And the second part, the copper has a lower resistivity or greater number of the charge carrier. So number of charge carrier for copper is greater as compared to that of steel. But student states that the drift velocity of electron will be same in the both cables. So first we have to understand what happened to the current. They mention here, if you see this part, that the potential, the same potential during the potential between the metal rod and the ground is also same. So we have the formula V equals IR. If V equals IR, so V over R is equals to I. The potential is same as I mentioned. The copper is having a low resistivity, because low resistivity means low resistance will also be there, because R is equals to rho L by A. L is same, A is same. Resistivity is low. If the resistivity is low, it means it will have a smaller resistance. So if it will have a smaller resistance, if the resistance decreases, so what happened to the current? The current will increase. So if the current is increasing, it means the number of the charge, already in the question they mentioned the charge carriers are increasing. So this increase in current might be increase in the charge carriers, not because of change in the drift speed. So student answer may be correct. Why? Because when the copper is having, as we know, like it is having a same area and length, but different resistivity. If resistivity is smaller, resistance of the same length of a wire of copper will have a smaller resistance. And the potential is same. So if it has a smaller resistance, means there will be more current in the copper as that compared to steel. And if there is more current in the copper, that increase in current might only be because of increase in the charge density, as the copper is having more charge density. So the drift speed will be same. But this might be same or may not be, because we have to why may because the current is increasing, so current can increase. Maybe both of them have increased, or maybe one of them is increased. So this statement, when you write your answer, you will mention that student statement may be correct because the current is increasing, so it may increase because of the charge density, or there's a possibility that the current might increase because of increase in charge density and the drift speed both. So student statement might be correct, not 100% true, but its statement might be true. So the points you will mention here, that the copper resistance is low. As a result, more current in the copper wire. As there is greater current in the copper wire, the greater current may be due to increase in the number of charge carriers, or the drift speed. Instead of saying or, it should be and, because charge carrier is already increasing. So student statement might be correct if it was only due to increase in charge carrier, then student statement might be correct. Or if both are increasing, then the student statement may not be correct. So the third point you have to mention about the possibility, like there is a chance that student statement might be correct, or there is a chance maybe not be correct as well. So both are acceptable. In question 7, the resistance of a particular thermistor varies with the temperature as shown. A student connected the thermistor in series with a battery and a resistor, and at 45 degrees, the resistance of a thermistor was 4 times the resistance of a resistor. The power dissipated in the resistor is 0.38. So at 45, we have derived this equation. So how we can derive this equation? We have the formula, the power P is equals to VI, and then we have the formula I is equals to V over R. So P is equals to V, and in place of I, V over R. So this will become P equals V square divided by R. The next part, determine the potential across the battery. Means we need the total voltage. At 45, the resistance of a thermistor is 4 times the resistance of resistor, and the power dissipated in the resistor is 0.38 watt. So at 45, when we work out, because the graph is given, so you have to use, and you have to show this on your graph. Like when you draw a line from 45, 10 boxes equals to 20. So each is representing 2. So 42, 4, 6. So this will be 45. 30, and 10 boxes equals to 10. So each is sorry, 10 boxes equals to 20. So each is representing again 2. So this will be 34. So resistance of the thermistor from this graph is equals to 34. And So if this is 34 resistance is there, and the resistance of thermistor is 4, so means resistance of thermistor is 4 times the resistance of resistor. This is the equation. So if we need the resistance of resistor, so resistance of thermistor divided by 4 will give us the resistance of resistor. So example, if this was 34 ohm, this will be 34 divided by 4. So 34 divided by 4, that is 8.5. So this will get it 8.5 ohm. And we need a, so what we can do, we can work out the total, like we have the power is there, which is dissipated in the resistor. So the power which is dissipated in the resistor is 0.38 watts. So using this power and resistance, we'll find how much current will be there. And that using that current, the same current will flow through a thermistor. So using that current, we'll find the potential across the thermistor, and using the power and the resistance, we can work out the voltage. Even, and then you will add, you will get the total. There's also another way, because in the question they mention if this resistance is R, like resistance of thermistor is 4 times the resistance. So means the ratio, we can work out the voltage or a potential here by using a formula P is equals to V square over R. And then the potential here, because this resistance is 4 times, so the potential will be 4 times compared to this one. Because in a series circuit, the ratio of the resistance is same as the ratio of potential. Like if this was like 3R and this is R, so the voltage will divide in the same manner. Like if this was 6, this will be 18. So using this, we work out the resistance. So multiple ways you can solve this. After working out the resistance, P is equals to V square over R. So power is 0.38 and V square divided by R resistance 34, 34, 35. So 34, then 0.38. No, not actually 34. It will be 8.5 because so using this, we'll work out the current, the voltage, and then it will be 4 times. So 45, this is 45. Yeah, around 34 is there. So we have V square. And what about the resistance? This will be 8.5 divided, we multiply. So 0.38 multiplied by 8.5, we take a root. You will get, what's the answer here? 0.38 into 85, 8.5. That will give us the potential across the fixed resistor. Zero 0.38 into 8.5, take a root. What is the potential across the fixed resistor? 0.79, okay. So 1.79. So we got 1.79 volts. So 1.79 volts or 1 and 1.8, 1.79. So 1.79 volts here. How much voltage? Because this is resistance is 4 times, so the voltage or a potential, this will be 4 times. So 1.79 multiplied by 4, that will be 7.16. So this will be 7.16 volts. And the total will be the sum, because the battery potential of a battery divided between them. So 7.16 plus 1.79, that will give us 8.95. So this battery will be 8.95 or approximately 9 volts. Is it clear, this one? Explain why increasing a thermistor decreases the temperature. So increasing a why resistance of a thermistor decreases when temperature increase. So we have the formula I is equals to NAVQ. So what actually happens when a temperature increase, drift speed will decrease because more random motion. But what happened? More charge carriers. It's a semiconductor. More charge carriers, so current will increase. And if the current will increase, V equals IR. If the potential is constant here, so if the current is increasing, the resistance will decrease. So because for semiconductors, when we increase the temperature, there are more charge carriers. As more charge carriers, even though the drift speed decreases, but the increase in the charge carrier is more than the decrease in the drift speed. That's why current will be more. As there is more current for the same potential, so the resistance of a thermistor will decrease. Then the last question, a student increases the temperature of both wire resistor and the thermistor from 80 to 90. Why the current in the circuit is decreasing? So we have a thermistor is there and we have a fixed resistor or a wire is there, wire resistor. So what is the effect of increasing temperature? When we increase the temperature, what happened to resistance of the wire? That will increase because lattice vibration increases and drift speed decreases. For a wire, what happened? They have the same current. So I is equals to NAVQ. And this also I is equals to NAVQ. So when we increase the temperature of the thermistor, its resistance is decreasing. But when we increase the temperature of a wire, its resistance is increasing. So here what happened? This number of charge carrier won't change for a conductor. Area is not changing. So means as a result, what will happen? That because drift speed decreases with increase in temperature. Here drift speed decreases, so the current should decrease. Here what happened? Area is constant. This Q is always constant. So when we increase the temperature, number of charge carrier increase and the decrease in drift speed. So as a result, what should happen? The current should increase. So for a metal, when we increase the temperature, the lattice vibration increases. So as a result, the drift speed will decrease or a resistance will increase. But the current, like for this part, the current should decrease. For this part, current should increase. Now, so overall resistance here will increase and overall resistance here will decrease. So one resistance is increasing, another resistance is decreasing, but as a result, what will happen? The current in the circuit has decreased. So if the current in the circuit has decreased, so it means increase in the resistance of the wire is more than the decrease in the resistance of thermistor. That's why overall circuit resistance, which will be the sum of these two, the overall circuit resistance will increase. So the points you will mention that one is like when a temperature increase for a metal, the lattice vibration increase, so which reduces the more collision of electron with the lattice of the positive ion, so which reduce the drift speed. And drift speed decreases, so the current should decrease, or we can also say the resistance should increase. And for thermistor, what should happen? As the high temperature, more charge carriers and smaller drift speed, but increase in the charge carrier is more. So overall circuit resistance current should increase, so the circuit resistance should decrease. But because in actual what happened, there is a decrease in the current in the circuit. So if the decrease in the current in the circuit means the amount of increase of the thermistor of the fixed resistor is more than amount of resistance decrease for a thermistor, That's why the overall circuit resistance will increase. How we how we know fixed resistor should have a greater resistance? Because in the question they mention the current in the circuit is decreased. Because they mention the total current in the circuit has decreased. So if the total current in the circuit have decreased, it means as there is an ammeter connected, so this will, if we increase the temperature, the thermistor resistance is decreasing. But and the fixed resistor resistance is increasing. But how we know that which is more, like increase is more or decrease is more? Because in this statement, the current in the circuit has decreased. So it means the resistance increase in resistance is more than decrease in resistance. That's why the current in the circuit has decreased. So this was the pop quiz 7.